Hey everybody, this is Gregory from Dapp University. So in this video, I'm going to talk about how Ethereum works, and I'm going to cover it all. I'm going to talk about cryptocurrency, mining, smart contracts, gas, consensus mechanisms like proof of work, proof of stake, Ethereum 2.0, Casper sharding, everything, you name it, I'm going to cover it in this video. So you're going to want to stick around and catch the whole thing. So before we get into that, be sure to subscribe to this channel if you haven't already and click the like button down below. And as always, you can download my courses for free on my website over at dappuniversity.com/free download. And this video is actually a preview for content that's inside of my online blockchain developer bootcamp. The bootcamp is the best way for you to become a highly paid blockchain developer, and it launches on May 15th, 2019. And you can find out more about it down in the description below. So I made this video as a sneak preview of some of the content that's going to be inside the bootcamp. So like the content that's in this video is actually part of the bootcamp, and I wanted to release it as a preview so that you can get a taste of what's inside. So without further ado, let's talk about how Ethereum works. What is Ethereum? Well, it's a lot of things. Most people know Ethereum as a cryptocurrency, and it is a cryptocurrency. You can see the information, here on CoinMarketCap about Ethereum. It's a cryptocurrency with a price, that can be expressed in US dollar, that can be bought and sold on cryptocurrency exchanges. It works like any other cryptocurrency. You can send it to other people. You can use it to pay for things. It can be held in a cryptocurrency wallet like MetaMask. Like you can see, so I've got some Ether here in my MetaMask wallet. But Ethereum is more than just a cryptocurrency. It's a blockchain. And it's a blockchain that has a native cryptocurrency. That's what Ether is. It's the cryptocurrency of the Ethereum blockchain. And, most of the time people just call it Ethereum. But Ethereum is, a blockchain application platform. It's a general purpose blockchain that allows you to send its own cryptocurrency to other people, but it also allows you to run programs with smart contracts, like a decentralized world computer. And we can actually see Ethereum running here. Here's a website, etherscan.io, that lets you take a look at the status of Ethereum and what's happening right now. And what does this information mean? You can see this thing here, latest block. What does that mean? This transactions per second. What does that mean, right? What are these transactions? What are these blocks? Well, there's a lot that can be said here, but high level, a blockchain, in one sense, is a database and a network that consists of transactions. Anytime I send Ether from one account to another, it creates a transaction. And these transactions are grouped together in bundles of records called blocks, which are chained together to make up the blockchain. You can see a list of recent transactions here. You can see the blocks that they're grouped into. You can see the latest block, and so much more. In order to understand where Ethereum came from, let's talk about Bitcoin. I've got the famous Bitcoin white paper pulled up here, which offers an explanation of how Bitcoin works. So Bitcoin was created by the mysterious Satoshi Nakamoto, and the introductory sentence gives us a clue to Bitcoin's core purpose. It says a purely peer-to-peer version of electronic cash would allow online payments to be sent directly from one party to another without going through a financial institution. So Bitcoin is created as an alternative financial solution that removes central authorities from governing money. And it does this by distributing balances with a ledger that's shared by every device on the Bitcoin network. And this is where the idea of a blockchain network comes from, a peer-to-peer network of nodes that share a copy of all the transaction data and participate in representing everyone's account balances. That's the main idea of Bitcoin. We don't really hear that term, the blockchain, until people started realizing that the Bitcoin technology could be used and generalized for other purposes. It could be used to represent and store other value besides just money, and it could be used to create programs that could run on blockchains in a decentralized way with smart contracts. And that's where Ethereum comes into play. Ethereum was created by Vitalik Buterin and was officially launched in 2015. And Vitalik had this vision for a general purpose blockchain that could run arbitrary programs with smart contracts to create a world computer. And we can see here on the Ethereum website that they describe Ethereum as a decentralized platform that runs smart contracts, applications that run exactly as programmed without any possibility of downtime, censorship, fraud, or third-party interference. So how does Ethereum work? Well, it's a blockchain with a native cryptocurrency that can be sent, it can be bought and sold on cryptocurrency exchanges, it can be mined, it can be stored in hardware wallets or cold storage, and it can run smart contracts. So let's take an in-depth look into how that works. In order to use Ethereum, you first and foremost need an account. And this account is going to be used to track your balance, how much Ether you have, in your wallet. And your account is basically comprised of a set of key pairs, your public key and your private key, right? Your private key is kind of like a password that you use for the network. It's secret. You don't want to share it with anybody. And your public key is kind of like a username, right? And you might have seen your Ethereum address. Well, that's a representation of your public key. And whenever you connect to the Ethereum network, you're a user of the entire network. And if you're using a Dapp or talking to smart contracts on the network, you're not just a user of those applications. You're actually, a user of the whole network. So you can think about Ethereum in three ways. It's a network, it's a database, and it's a computer. So I'll explain those three things. Ethereum is a peer-to-peer network of nodes that all talk to one another. Each of these computers or nodes handles the computational overhead required to run the network, and they all talk to one another. It's just a network or a web of nodes. And in order to use Ethereum, you need access to a node. So you either have to run one yourself or connect to it with a URL. And the node you connect to is going to act on your behalf for the entire network. So Ethereum is also a database. It's a database of transactions that, store the entire history of transactions on the blockchain. And that's used to build your account balance and things like that. It's also used to build a state of smart contracts. And all these transactions are grouped together into bundles of records called blocks, which make up the blockchain. So because Ethereum is basically a distributed computer, each node in the network gets a copy of all the code that's run on the blockchain. All this code is written in smart contracts, which are just programs that run on the blockchain. And we'll talk more about those here in a minute. So let's talk about mining. So Ethereum supports mining, but what is mining and why does Ethereum have it? Well, if you go back to our diagram and you look at these nodes in the network, some of these nodes are miners and they participate in the mining process. So what is the mining process? Well, whenever you create a transaction, for example, if I want to send you 10 Ether, that transaction has to get written to the blockchain. And some of the nodes in the network participate in doing that. These nodes, called miners, basically compete to solve cryptographic puzzles. And the miner that solves the puzzle first is the one that records your transaction on the blockchain. And this miner is rewarded with cryptocurrency. They get Ether for solving the puzzle first. And that cost is paid by the person who sent the transaction. So this is all part of Ethereum's consensus algorithm, which is called proof of work. That's currently what Ethereum runs off of. Whenever a miner mines a transaction, they submit their proof of work in order to include the transaction on the blockchain. So let's look at how that works in depth. Whenever you submit a transaction on Ethereum, you pay a small fee in addition to the amount of Ether that you're trying to send. So let's say I want to send 1 Ether to you over here. So a lot happens in between from the time that I send it to the time it comes to you. I need to send my 1 Ether amount plus a small transaction fee in order to make the transaction happen, to debit it from my account and credit it to yours. So in order to send the Ether cryptocurrency, I submit my transaction to the network, and the network basically creates a cryptographic puzzle that the miners need to solve. And the miners compete to solve this puzzle. They basically do this by creating a bunch of digital guesses, and each of these guesses gets run through a hashing function. And each of these guesses get compared back to the original puzzle solution. And whichever miner guesses the solution first is the miner that wins the competition and is rewarded the fee that I sent with my transaction and mines the transaction and includes it into the blockchain. And whenever it gets included on the blockchain, your account balance is updated and my account balance is also updated. Mine goes down and yours goes up. So that's an overview of how mining works with Ethereum's proof of work consensus algorithm. Let's talk about security. Why is it safe to store transaction data on a bunch of computers that anyone can access? Well, that's because it's nearly impossible to tamper with the data that's stored on the blockchain. So for example, why can you trust the blockchain to say that you have $100 worth of Ethereum cryptocurrency in your account if everyone has a copy of that information and it can be changed? Well, it's actually really hard to change your balance. Here's why. In order to change or tamper with your balance, you would have to change all the transactions in the past. See, your balance is made up of all the transactions that have ever happened on your account. And if you're going to change it, you have to change all the transactions that happened to create this balance and all the subsequent transactions on the blockchain. And it would take an incredibly powerful computational resource in order to do that. And therefore, it's nearly impossible. So basically, if you were going to do it, you would have to recompute the block where the transaction occurred and then recompute every single subsequent block after that to catch up with the current state of the blockchain network. And this gets exponentially harder with each transaction that gets added on the blockchain. So that's a high-level overview of why it's so hard. We're going to talk about that more in the Bootcamp section where I explain cryptography and how it's used on the blockchain more in depth. So this is called a 51% attack. And the reason it's called that is because you would have to control 51% of the network's computational power in order to tamper with the blockchain's history. You would need a mining node or a pool of mining nodes, and you would need an unreal amount of computational power to do this. And it's virtually impossible on Ethereum. So let's talk about gas. This is a fundamental concept for Ethereum. So if you remember a few slides back where I talked about, paying fees to miners whenever you send your transaction, this is called a gas fee. And you have to pay this gas fee anytime you create new transactions on the blockchain. So why do you have to pay to use Ethereum? Well, that's because of Ethereum's current consensus algorithm proof of work where we talked about mining. If you're going to mine new transactions on the network, you need a computer that does this, and that costs money. Someone has to, use their computer for this, and they need to be incentivized to do it. And they're incentivized by getting paid. And that cost is passed on to the user who's sending the transaction. Let's talk about how gas actually works. So if I pull a MetaMask here and I want to create a transaction, I want to send 1 Ether, right? I would be sending 1 Ether with this transaction, and then I would additionally pay a fee. So you see some options here, slow, average, fast, and go to advanced options. So what do some of these numbers mean? So the gas price, the gas limit. So this is actually an amount of gas, and this is the amount you pay for gas. So this can be kind of confusing the first time you look at it. This gas amount right here is a unit in itself. Gas is basically an abstract unit. Think about it like buying gas for your car. Your gas amount, the amount of gas you use is expressed in maybe like liters or gallons, depending on where you live. And the price is, expressed in your local currency. If you live in America, then you have a gas price that's expressed in cost per gallon. And you can think about this gas amount as kind of like a gallon or a liter. And the price is expressed in Ether. And now this is not necessarily 10 Ether. This is a smaller denomination of Ether called Gwei, which is basically Ether divided by several decimal places. So to get the total amount of gas, you just multiply the amount of gas that the transaction consumes by the gas price to actually get the amount of gas that's going to get paid on the transaction. And you can see it here. If I send 1 Ether, then the transaction fee is going to be 0.00021 Ether. And we can see the total amount that I'm going to send on this entire transaction is 1, which is the amount of Ether I'm sending, 0.00021 Ether, which is going to be the transaction fee or the gas paid to the miner, just added to that. Now, I should also mention the difference between the gas limit and the actual amount of gas that gets produced or consumed in the transaction. So this is a limit of 21,000 units of gas, which basically means that I'm allowing this transaction to get sent, and I'm not going to allow it to consume any more than 21,000 units of gas. So that's really helpful if you're talking with smart contracts and you say, hey, I don't necessarily trust this thing. I'm only going to allow, the network to spend this much. And you can see the actual amount of gas consumed by the transaction whenever you look at the transaction receipt on the network once it's actually mined. But in this case, we know exactly how much gas it costs in a basic transaction. It's always 21,000 units of gas. So it's safe to set the gas limit to the actual amount of gas consumed when you're just sending Ether back and forth. We always know it's going to take 21,000 units of gas just to do a basic transaction on Ethereum. So here's a really helpful resource. This is ETH Gas Station, where you can see a lot of information about current gas prices. So also notice, like in MetaMask, I show you, let's see here. If I want to create a transaction, you can choose it gives you some options for gas prices. So you can see, gas amounts. You can see slow, average, and fast, right, for the total amount of Ether. So basically, less gas paid to the network creates a slower transaction, and more gas you pay, the faster the transaction. So it kind of gives you some preset defaults. And you can see like how long it takes to actually mine transactions on the blockchain. And that's what this is a great resource for. You can say, you know, if you enter in all these parameters with this much gas used, this gas price, this is how long it's going to take, right? You can see some current network stats on how long you have to wait for that to be mined. You can also look at a transaction calculator that says, you know, if I basically enter this amount, let's say I want to send Ether, so I do 21,000 units of gas, and let's say I pay 50 GUI for it. You know, how long is it going to take, and how much is it going to cost? So basically, it's going to take 22 seconds to confirm the transaction, and it's going to cost 18 cents in US dollar. So this is a really helpful resource for you to use whenever you're trying to learn about gas, and learn more about the Ethereum network and how gas works with transactions. Let's talk about smart contracts. So smart contracts are programs that run on the blockchain, and they are the building blocks for decentralized applications that run on Ethereum. And they're kind of like vending machines. Basically, they're programs that you know how they're going to behave every single time. And you go usually put money into it or send money with your transaction, and you know exactly what's going to happen. Something's going to come out, or something action is going to happen on the blockchain. So it's kind of like a vending machine in that regard. And it's called a contract because it essentially represents some kind of covenant or agreement that something's going to happen. You know, if you do something, then the contract is going to do something. And it's a contract because it's always going to work the same way every time. It's smart because it runs on a computer. And these smart contracts are accessible to everyone on the Ethereum network. So they're sort of like a microservice or an API in that regard. You know, they allow you to interact with Ethereum programmatically. They have an interface that anyone can access, and they can read and write data from the blockchain and execute business logic. The smart contracts are written in a language called Solidity that looks a lot like JavaScript. This is just an introduction to how smart contracts work. I'm going to show you how to code smart contracts in the introductory section on Ethereum smart contracts in the Bootcamp, and then we're really going to go in depth when we build the Bootcamp capstone project. We're going to build some real-world smart contracts that run on Ethereum. So let's talk about tokens. So what is a token? Well, Ethereum allows you to create your own cryptocurrency without creating your own blockchain. It's actually a really nice feature. It allows you to do this with smart contracts. And these smart contracts give you the ability to write Ethereum-based tokens that run on the Ethereum blockchain. This prevents you from having to create your own blockchain and convince a bunch of people to run your nodes in order to do it. You can just take advantage of Ethereum's power and create smart contracts to create your own cryptocurrency. So Ethereum specifies a standard for how tokens should work. It's called ERC20. You can see more about that here. Basically, this just describes how the token should work in code. It describes the functions that it has to have, you know, all the properties and behavior that it is required to have. And I'm going to talk more about this in the introductory section to tokens, and we're definitely going to get our hands dirty whenever we build our own token in the capstone project. But I want to just give you an introduction to this ERC20 standard here. So here's an example of an ERC20 token that's running on the main Ethereum network. This is OMG. We can actually verify, you know, that this contract is using the ERC20 standard by going to the contract page and reading the code. You know, we can basically browse this and see that it, you know, implements like a transfer from function. That's an ERC20 function. You know, we can see lots of other stuff. You get the balance of. You can browse through, you know, this entire standard and just verify that the token works like we think it does. Let's talk about Ethereum 2.0. So Ethereum is awesome. It's a great general purpose blockchain that runs smart contracts like a world computer. But the team behind Ethereum is always trying to make it more powerful, more scalable, all that kind of stuff. And that's what the vision for Ethereum 2.0 is. So what is Ethereum 2.0? Well, it's not just one thing, it's a lot of things. They're trying to seek to optimize Ethereum and make it more scalable. And I want to dive into some of the things they're going to try to do with Ethereum 2.0 right now. Let's talk about why we want Ethereum 2.0. Well, there are some current limitations of the network as it is. For example, it only supports about 15 transactions per second. At least that's the advertised transactions per second, or TPS. And if you have high traffic on the network, then the TPS can be a bottleneck. This was made famous at the end of 2017 when CryptoKitties launched. Basically, the network got clogged up and there was a log jam that caused transactions to take a very long time to be confirmed. Another limitation is block time. This is the actual amount of time it takes for transactions to get included into blocks. So even if network traffic is low and it's free and clear, it still takes a fixed length of time for transactions to get included on the blockchain. And this number is a big variable. So transactions per second is a limitation of how many transactions can fit through, the bottleneck at one time. And then block time is the actual amount of time it takes for the transaction to be processed, once it gets through this bottleneck. And another limitation of the network is, just the actual duplication of responsibilities, like the fact that it takes the entire network to participate in confirming transactions and things like that. So let's talk about some of the solutions proposed by Ethereum 2.0 to kind of help some of these current limitations. And these are organized into layer 1 solutions and layer 2 solutions. And layer 1 solutions are basically improvements to Ethereum itself, like just the actual blockchain layer. And layer 2 solutions are basically solutions that are going to be built on top of the layer 1 Ethereum to provide some extra functionality that will make it more scalable, more usable. So for example, you could create a layer 2 solution that would speed up some processing and then settle the eventual result on layer 1 Ethereum. So we'll talk about some examples of that here in just a second. So what are some layer 1 solutions? Well, one is called sharding. And remember how I talked about it takes the entire network to confirm transactions. We can break up that responsibility into smaller groups of computers on the network. These smaller groups would basically be called shards. And instead of, the entire network having to participate in this, these smaller groups could, handle this responsibility, and they could operate all at the same time or concurrently. And this would greatly speed up the transaction time on the network. It would eliminate some of the bottleneck because you wouldn't have to do everything, serially in sequence. You could do a lot more things concurrently. So let's talk about Casper, which is proof of stake. So earlier we talked about proof of work, which is Ethereum's current consensus algorithm that supports mining. Well, there's a hope to move to proof of stake, also known as Casper. This is a different consensus algorithm where people basically lock up Ether or stake it in order to become validators. And the validators are the ones that include new transactions on the network. So the big benefit of proof of stake in Casper is it reduces block time and helps scaling. Let's talk about layer 2 solutions. One layer 2 solution is called Plasma. Plasma allows for some of the computational activity of the blockchain to be processed on a side blockchain called a side chain. This side chain is going to allow us to still operate in a decentralized, secure way to handle some of the processing, to offload it from the main chain and handle it on a side chain. And this allows us to do things concurrently instead of having the main chain need to do everything one by one. And if you do something on a side chain, it's going to happen securely, and you can put the result of whatever happened on the side chain back on the main chain as a settlement layer. Another layer 2 solution is state channels. This works kind of like Plasma or side chains where, you handle some other activity off of the main blockchain on a layer 2 solution. So a state channel works differently. It's not necessarily a blockchain. It's a two-way communication channel that allows you to make a bunch of transactions back and forth, and then you can get the eventual result of that or the sum of that and then put it back on the main blockchain. So as an example, I could send 5 Ether to you, and then you send 2 Ether back to me. And then I send you 1 more Ether. So that's an example of 3 transactions. Normally we'd have to do all this on Ethereum, but instead we could do it on a state channel. And the eventual result would be that I have 1 Ether and you have 4 Ether. We could take this result and put it back on layer 1, which would just be Ethereum itself, as one single transaction. So like I said, Ethereum 2.0 consists of a lot of different efforts, and it's going to be a combination of all these efforts that really makes Ethereum fast in the long run. Here's an article where Vitalik talks about reaching, 1 million transactions per second with Ethereum. He says, so if you get 100x from sharding and 100x from Plasma, these two basically give you 10,000x scalability gain, which basically means blockchains will be powerful enough to handle most applications most people are trying to do with them. So that's an idea of where we could go with Ethereum 2.0. So if y'all like this video, Again, this has been a preview of some of the content from my Blockchain Developer Bootcamp. It's your ticket to becoming a highly paid blockchain developer. There's so many more in-depth videos like this one. And inside the Bootcamp, we also build a real-world project that'll teach you how to be a real-world blockchain developer. So check out the link below for more details on how to get into the Bootcamp. And until next time, thanks for watching Dapp University.